want to walk you through what's actually happening inside a neuron during a concussion, and this physiology that underlines everything we do on the sideline and in return to play decisions. First thing to understand, a concussion isn't a structural injury. There's no lesion you'll see on a CT or MRI. What's actually happening is a self-limited disruption of ion homeostasis and energy metabolism inside the neuron. It breaks down into three phases: a mechanical trigger, an ionic cascade, and ultimately a metabolic crisis. Let's walk through each step. It starts with mechanical force, rotational or linear acceleration that stretches the axon and synaptic membrane. That stretch opens mechanosensitive and voltage-gated channels, and potassium rushes out of the cell, collapsing the resting membrane potential. Clinically, this happens within seconds of impact, well before any symptom shows up on the sideline. Efflux triggers glutamate release, which further depolarizes the neuron and spreads the disturbance to neighboring cells. To restore the ionic gradient, sodium-potassium ATPase pumps kick into overdrive, burning through ATP at an accelerated rate. That drives glucose utilization far above baseline, which is what we call hyperglycolysis. Causes voltage-gated calcium channels to open and calcium to flood into the cell. Unlike the potassium and glutamate changes, calcium dysregulation is prolonged and is directly toxic to the mitochondria. So here's the critical mismatch. Right when the neuron's energy demand peaks, cerebral blood flow actually falls. So you have rising demand from the ATPase activity and hyperglycolysis, falling supply from reduced blood flow, and the result is mitochondrial dysfunction, a true energy crisis. This vulnerable window is a psychologic basis for gradual return to play protocols. What does this mean for us clinically? First, symptom recovery outpaces metabolic recovery. An athlete can look and feel fine well before the cascade has actually resolved. Second, that's exactly why cognitive and physical rest makes biological sense in the acute phase. Third, a second blow during this energy crisis window, even a small one, hits a cell with almost no metabolic saved up, which is what drives second impact risk. And that's why we use progressive stepwise return protocols rather than an all or nothing clearance. Right, here are a few key takeaways. A concussion is a functional metabolic injury, not a structural one. The cascade folds in a sequence. First is the potassium efflux, then which leads to glutamate release and hyperglycolysis, then to a calcium influx, which ultimately ends in an energy crisis. The cerebral blood flow drops just as energy demand peaks, producing a supply-demand mismatch. Calcium dysregulation and full metabolic recovery may take days, longer than symptom resolution. This physiology reinforces the importance of rest recommendations, gradual return to play, and second impact syndrome risk. Thanks for listening.